Alright, so you've mastered the art of single-digit multiplication. You might be wondering, what's next? Well, you're in luck because your current skills have unlocked a whole new world of upper-level mathematics just waiting for you to explore it. To begin our adventure, let's wander a little deeper beyond the shores of Multiplication Island. What happens when we're not just multiplying single-digit numbers anymore? Let's dive in. The best way to wander down this path is through examples. Take something I'm sure you're all familiar with. 3 times 4 equals 12. What would happen if that 3 magically became a 30? Well, for starters, there's nothing that just simply happens in math. There's an explanation for why this might occur. How might one get from 3 to 30? Yes, I know I added a 0, but the 3 moved from the ones place to the tens place. All that means is that 3 was multiplied by 10 to get 30. Or in more formal terms, 3 was increased by a factor of 10. So, if 3 times 4 is 12, but 3 must be multiplied by 10 to get 30, then our previous result must also be multiplied by 10 to solve 30 times 4. Therefore, 30 times 4 is 120. What if we added another 0 to 30 to make 300? Well, we already established that in order for the 0 to magically appear, we need to multiply it by 10. If we go back to our original example of 3 times 4, we want to add 2 zeros to 3. We need to multiply by 10 twice. And, as you know, 10 times 10 is 100. So, if 3 is being multiplied by 100, then we can multiply our original result of 12 by 100 to get the final answer. 300 times 4 equals 1,200. This pattern of multiplying the result of a single-digit problem by 10 multiple times, depending on how many zeros have been added to the terms, can carry on indefinitely for however many zeros you can dream of tacking onto that 3. Alright, hold on to your hats, we're about to get some wild things up in here. What if, instead of just continually adding zeros to one term, we added zeros to both terms, say 30 times 40? How would this result be different from the previous example of 300 times 4? Now, both the 3 and 4 have an extra 0, so they both multiply by 10. So doesn't that just mean we've multiplied by 10 twice, or 100 yet again? Yes, the result is still 1200. It doesn't matter necessarily where the zeros are located in a particular problem, just as long as you account for them in the final result. As a shortcut, in the example 30 times 40, you can count 2 zeros. So that means you tack on 2 zeros to 12, or multiply by 100 to get your final answer. If I showed you 3,000 times 400, you can count 5 zeros. So, slap on 5 extra zeros to 12, or multiply by 100,000 to get your final answer of 1,200,000. I believe that you have made great progress on your path of crossing Multiplication Island, but there is still much work to be done. What if, instead of tacking on zeros, we tacked on other whole numbers, say like 34 times 46? Well, this is not so simple as just multiplying single-digit numbers by various factors of 10. But the sense of understanding what the different places of numbers actually mean is critical in tackling this task. We can all agree that 34 is equivalent to 30 added 4, and that 46 is equivalent to 40 added 6. This will be our crucial tool. Instead of looking at this problem and getting overwhelmed with how to deal with numbers of both the tens and ones place, break it down into steps you can easily swallow. Start with single-digit multiplication. So, where is the ones place here? 4 and 6. Oh, that's easy, 24. Now here, remember we aren't just simply multiplying 6 times 3. Remember, 3 is in the tens place, so it's actually 30. Essentially, with these first steps, we're breaking 34 into 30 and 4, and multiplying each of these individual terms by 6, then finally adding them together. 6 times 3 is 18, so 6 times 30 must be 180. So if we want to know what 34 times 6 is, we can just add these results together to get 204. Time to move on to the next set, 34 times 40. We can do the same steps here, but keep in mind that we've got an extra 0 here because 4 is in the tenths place. Again, let's stick with starting in the ones place. 4 times 4 is 16, so 40 times 4 is 160. Next, 3 times 4 is 12, so 30 times 40 is 1,200. Alright, we've got our parts. Let's add them together. 40 times 4 plus 40 times 30 is 1,360. So how do these two problems work together to get the answer to 34 times 46? You might have already noticed that we actually already used our superpower of splitting up the individual terms and can now just add the results. We just solved for 34 times 6 and 34 times 40, and we know that 40 plus 6 equals 46, so now we can say that 34 times 6 plus 34 times 40 equals 204 plus 1,360 equals 1,564. Yes, we did it! Now drink some water. That was a lot of hiking across this island. So we've got what this process of multi-digit multiplication is doing, but isn't the work a little bit messy? I mean, I know I would get lost attempting to search through all of that to get a final answer, so let's condense it a bit. We're still going to be breaking the numbers apart step by step, but we're going to keep them all together in little boxes so we can be organized, just like my room.
Is certainly not.
To keep things straight, let's draw some lines between each of the places so that the numbers don't all mush together when we get deeper in the thick of problem solving. When we multiply 6 and 4 to get 24, we can put the 4 down here in the ones place because there are no other numbers we're multiplying that would contribute to the ones place. But now we're left with that 20 here, so let's pop a 2 up above the 3 and 34 because it's already in the tens place here, so no extra zeros required, so that we remember to add it back in with the next step. 3 times 6 is 18, but oh yeah, there's a ones place already filled. We can add in the 2 to our 18 to get 20 and file that in right beside our 4. This just condenses all of that separate multiplying and adding from the previous method all into one convenient step, and notice we still get the same result of 204. Next, notice here that we do not have a ones place. We are multiplying not 4, but 40 times 34. Therefore, our first step now is to place a 0 down here in the ones place. Do not forget this step. Now, we may proceed with filling in our numbers. 4 times 4 is 16, so place your 6 down here in the tens place, and place the 1 now above the 3. We can ignore the 2 now, because that has absolutely nothing to do now with what we were multiplying. Do not fall for its mind games. Three times 4 is 12. Don't forget to add back in that 1, and boom, we've got 1,360. Now it might be easier to notice where the 36 times 6 and the 36 times 40 show up in this process. Finally, just like we did before, we can add these terms down below, and bingo, we get the same result of 1,564 as before, just in a much more clear and concise manner. Congratulations! You've just conquered a key step on your journey through the mathematical multiverse. Use these tools I've offered and apply them to any and all multi-digit multiplication problems to infinity and beyond.